Hi everyone, I'm Yuding from the Teaclave project, and today I'm gonna uh, present the Rust SGX SDK's historical review in the past 4 years. And to, in the beginning, I want to introduce myself a bit. I'm Yuding, and I am not a pure security scientist right now, but I am a combination of scientist and engineer now. And I've been a security enthusiast since I graduated from college. And yeah, to be a geek, I'm really thirsty for performance and program correctness. So that's the reason why I dedicated to Rust and Intel SGX. First of all, I want to thanks to our contributors in the past 4 years. I highlighted two of them in red. It was my past colleagues. Since we have some difficulties to access GitHub from mainland China, so their code was committed by me and pushed to GitHub. So their names was hidden behind of me, but I have to say thank you to my guys. And then we have a small community, more than 20 committers. And then I want to thanks to the contributors as well. And for those people who are not familiar with Rust SGX SDK, I want to first brief a bit. It is now a incubator project under Apache Foundation. It was previously Baidu Rust SGX SDK, and it was open sourced in 2017. And it is designed to help people build enclaves in Rust and enjoy from the performance, security guarantees, and Intel SGX memory encryption. The major part of that project is a ported standard library of Rust, and we renamed it as SGX TSTD. It's tailored for Intel SGX. The major difference between Rust SGX SDK and the Fortanix SGX EDP is that our tailored standard library keeps only the compatible part of libstd, and we removed or renamed some small amount of code. And the entire SDK provides several useful creates, and this creates binds to Intel SGX SDK for something like attestation, crypto primitives, and that will help people better help onboard to Rust SGX SDK smooth as long as they read the document from Intel. And we have a lot of ported creates, and I test them every day and audit them every day. And the sentence I want to guarantee is that the last sentence, if it builds, it works and it's trustworthy. So I want to solve most of the critical problems during compilation instead of during execution. And I collected all of the locations from our GitHub stargazers. And we can see that Europe, China, and the United States are the three most popular area. And we have stargazers from Australia, New Zealand, Brazil, and almost everywhere in the world. And seems to get a hit. And I use another tool to create a history of stargazer curve, and we can see that the earliest SGX project was Panoply. It was a research. It was Graphene, right? Graphene. And the second one is Fortanix SGX. Previously, it was Jethro's personal project, and then it was renamed to Photonics Rust SGX. And the third one is Intel SGX. And next, we have Panoply and Rust SGX. For now, in 2021, the Rust SGX SDK has the most GitHub stars, but Google Silo is pretty close to us. And first, I want to talk a little bit about the very beginning, why we started this project. At that time in 2016, my team, the team I was in, was focusing on security in software and safe system. And we have a paper named War in Memory discussing about every kind of memory corruptions. And that was old topic, but that's classic. And we then understand that SGX Enclave should be immune to memory bugs, because SGX Enclave is designed to protect secrets, and the secrets could be very valuable, such as the decoding key of Blu-ray discs. So we want to guarantee memory safety in SGX secure enclaves. Then we evaluated two most popular programming languages, Rust and Go. And that was in 2016. And both of the languages are not very mature or not well completed yet. So we did a comprehensive research, and finally Rust won this competition by its simple runtime, or it has a very clear and a minimum runtime, and it depends on POSIX libc, and that's what Intel SGX provide. So we decided to go with Rust. And then in 2017, we have the first version released in the April. It provides only basic features, and it does only minimal bindings to Intel SDK. At that time, we do not even have printline macros. And then 3 months later, we released the second version. It contains a larger standard library, and at that time we had printline and some basic handy functions. And next, in October, we want to participate the iDash 2017 competition, and then we have to port a lot of, or I remember less than 10, not a lot of, less than 10 third-party creates to Intel SGX, and then we released a new version, provide almost full functional standard library there, and then we participated in the competition, but we are the last one. We had the worst performance. However, the CEA list research team from France won this task by using our SDK. Their solution is pretty amazing. They tailored a high performance concurrent hash map in SGX Enclave, and that is and they found a very efficient encoding for the data, and they solved the problem in 1 minute. But my solution is pretty trivial, and my solution ran in about 2 hours. That's I was really impressed by their solution. And 2 months later, we had our first paper published. It was a poster paper in CCS, and in that paper we first proposed the idea of hybrid memory safety, because our SDK is built and written in Rust, but we depend on Intel's trusted libc. We thought that Rust is good for system programming, but we cannot build everything in 100% Rust. That is a fact in the Rust toolchain and the current Rust ecosystem. We have a lot of C or C++ or assembly code in the entire ecosystem. And we proposed the rule of thumb for hybrid memory safety, and that contains 3 small points. We first need to minimize the unsafe code. It could be the inline unsafe code or external code written in C or C++, and which will be finally linked together. And second, we need to keep the boundary clear. That will be convenient for us for future maintenance and development. And then the third one is about runtime. The memory safe code and memory safe code should stay in their own memory. The memory unsafe code should not do something like arbitrary memory writing to the memory safe area. And the memory unsafe code should be managed effectively, such as what Intel is doing. As long as they upgrade the library, we can just simply download and link to the existing enclave, and we finish the upgrade. And that is convenient for us to upgrade. And so we choose to bind to Intel SGX SDK because we are not, we don't have enough human power to maintain the lower level of SDK, and then we trust Intel from the CPU's perspective, so we trust the software. Then we proposed the MESA family in the next couple of years. MESA stands for memory safe, and we have memory safe Linux distribution called Mesalog Linux, and we have a OpenSSL styled Russels and to provide a TLS termination, and we have memory safety Python and memory safety Armor. That's AppArmor's memory safe version. Okay, the next following years we're going very fast. In the next year, 2018, we supported Zago. It was a cross-platform cargo, and it's something like provide more convenient users, a convenient usage for our users. And in April of 2018, we released the first official version. And at that version, we ported the WebAssembly interpreter. It was slow, but it works. And we had the first official talk in Rust community conference in Paris. And then we got aware by the Rust community. And then we ported the machine learning libraries to run some training and inference job in SGX Enclave. And then 2019, we supported code coverage testing and a synchronized core, an IO core called Metal IO. And we did fork a lot of third-party queries and make them compatible with Intel SGX. And we had our second and third paper published, including a very fast gradient boosting engine and the final full paper for our SDK. In 2020, we have another paper in SCSE published. And next, I want to talk about something like interesting and hot topics of this SDK, the good, the bad, and the ugly. the good, performance, security, and flexibility. Since we are using the Intel's partition policy, so we have flexibility because user can partition their enclaves by themselves. But the bad is that we do not compatible with too many stuff, such as hyper or asynchronized frameworks, Tokyo, Crossbeam or something. We do not have piecewise fork, so we don't have too much parallelism. The ugly is about dependency. I will talk about this later. And for partition, it has been discussed for a long time, and I believe it's an art, and it should be done case by case instead of have a systematic way of doing partition. So first, good. Let's skip performance and security because we will talk a lot of sessions. We'll talk about performance and security in today. And for flexibility, I want to answer a question which is frequently asked. Is Rust SGX SDK or off-the-shelf SDK? Can we use it directly? Yes and no. For very simple use cases, you can just use it. And it provides a basic partition with most of the partition was dedicated to security instead of convenience. But if you want to develop something very complex, please maintain your own fork and do whatever you want. That's my recommendation. And for the bad things, the compatibility is much worse than Fortanic SGX EDP because they somehow they make their SDK a tier 2 target of Rust, and it could be built very smoothly with most of the off-the-shelf creates. But our SDK is not that easy to use. We have to manually port many stuffs and then fight against the cargo's internal problems and then get it compiled. To make it more easy to use, we have a plan to use std-aware cargo to replace the current trivial cargo. And that will happen not very soon, but we are making good progress. The ugly is about dependency. Before we donated our project to Apache, we have a large third-party directory in this project. It contains all of the ported creates. I remember it was 30 creates there. After donation, we create GitHub fork for each ported create. And we have 20 SGX machines to run the build tasks and test tasks every day for all of the forks. And we created a super crate, which depends on all of the SGX ported creates. And we run the build and audit pipeline every day as well. And most of the ported crates have a couple of enclaves to run the ported unit tests. And I can guarantee that if my test pass, it should be compatible with Intel SGX. And the picture, the ugly picture in the bottom of this page is the world map, the dependency map of the super crate, which depends on all of the ported crates. If you have done any ported jobs before, you will see some changes shown in this picture. Basically, the porting job is to replace the dependency from depending on crates IO to depending on our own forked creates repos. And we remove something incompatible. For example, we removed ATTY, which provide only one function to test if the current session is a TTY. And it helps the logger to choose if it should use color or not. Since Intel SGX should not be aware of the environment it was in, we removed this dependency from the dependency tree. And sometimes the ugly dependency is not that ugly, because we can fix something quickly without upstream support, and that sometimes related to security guarantees. Recently, we are processing a side channel vulnerability report that reported by a couple of researchers. They said that the Rust, which is a TLS terminator in SGX, has a side channel attack vulnerability in its base 64 decoder. That totally makes sense, and we can see that a boring SSL, which is maintained by Google, they have good design to have a constant time base-loose decoder for OpenSSL or for their boring SSL, but Rustls don't have that. They use the base-loose crate from crates.io, and it does not have constant time implementation. So we can fix this problem quickly by maintaining our own fork. And some other crates, such as non-CPUs, heap size, they do not compatible with Intel SGX. So I rewrite most of the code there to make it compatible. And we can add features for unmaintained but useful crates, such as Rusty machine. Many people wants to run the machine learning algorithm in SGX, but they need some more features about it, but it's not maintained anymore, so I maintain it. And we can test if a crate is compatible with SGX. That's the pain of all of the SGX SDKs or development environments. But we can do it well because I ported all of the unit tests. And we can find some bad things during compilation. Since we removed the file system by default from the standard library, we can find the import file system sentences from the third-party crates during compilation. If some crates want to write some secrets to untrusted file system, it will not compile. And we can be transparent by keep our porting commits always on top of the repo. And that will be convenient. If you look at the history of the ported repo, you will find only the top one is the new commit we made. And the previous one was exactly the same as the original repo. But the cargo, which is the dependency resolver of Rust, is problematic in a variety of ways. So I believe if you practice with Rust SGX SDK, you have wasted more than 100 hours in this era. Everybody wastes a lot of time there because cargo cannot resolve it effectively. And we did find a lot of bugs in the Rust community as well by checking the non-STD feature flag. So basically, we are replacing the default standard library with SGX standard library. So we have to make everything non-standard. And then we found a lot of bugs. The only way to confirm if a crate has clean dependency tree, which allows non-standard, is to use the code snippet listed below. This is the only way. We cannot trust Cargo Nano for that. And for some reason, Cargo has difficulties to differentiate between ref and tag. So Cargo will consider these two references as two different crates. but in fact, they share the same hash value and they are the same repo. But Cargo is not good at that. So it's still annoying currently, but we if you encounter this problem, I can help you debug. And a lot of ugly stuffs. I think I don't have enough time for that, and I will show you some interesting bugs I found in the past few years. The first one is about alignment bug. In the past, it was reported by Li Chai. The bug was something like complaining about unaligned memory chunk. The bug was caused by Intel SGX SDK's bug. By default, in x86 64, the memory allocator always allocate memory chunks aligned to 16 bytes. But Intel ported trusted libc does not make it right. It allocates memory chunks aligned at 8 bytes. But we inherit the value from default Rust lib_alloc. So we assumed the memory chunk was 16-byte allocated. So in Hashbrown, which requires strict memory alignment, it fails to run. It panicked during runtime. And then we have the second interesting bug here. This mutable or const keyword was wrong, had been wrong in the past 4 years. Nobody found it. And that's I think that's interesting. And I will have everything reviewed again this year to help find more inconsistency between Rust SGX SDK and Intel SGX SDK. And third, we ported a machine learning library there, but the performance is very bad. And we investigated a bit, and we found that the developer of the linear algorithm package was not very good at AVX instructions. And it always used AVX on compatible platforms, but in many cases, AVX is slower than traditional LLVM generated code. So we added some more features to disable AVX for users. So in the last, I want to say that there are many solutions for Intel SGX development, and some of them are saying they can do anything, but I want to say they may not be very fast. And for Intel SGX SDK, I think it's good, very good for limited cases, but we need to be very careful when using Intel SGX SDK because we have to run C or C++, and we have memory corruptions in there in such code. And I want to say Rust SGX SDK give unlimited possibilities to the community. And the futures, I don't have enough time for that. Let's skip. And I want to thanks to our communities. A lot of companies and projects are using Rust SGX SDK, and all of them provide very useful advices and fix a lot of bugs. And thanks to the community. And finally, thanks. And I will have 3 minutes to answer questions. Thank you very much.
Thank you. And thank you for having an eye on the. I know it's hard, but we told all our speakers that we have a strict timetable, and so everyone looking on the clock and tries to stay into the 30 minutes. Felix, you were in the chat. Do we have any questions for you? I think
yes,
we have 1 or 2.
Yes, a couple of questions. One is, does the Rust SGX SDK reuse remote attestation from the Intel SGX SDK?
You mean remote attestation?
Yes. So are you reusing the attestation primitives from the Intel SGX SDK?
No, we are not directly reusing the Sigma protocol or the remote attestation code samples algorithm. We have ported the SGX TLS or SGX RA TLS attestation code sample to our sample code, and it helps to establish a secure TLS channel that verify each other's SGX hardware report, and it's more convenient than the previous Intel SGX sample.
Okay, great. Yeah, thank you. I think we're on time for our next
Okay.
next talk. Yeah, I think if you have more questions for you, I think people can find you in the chat.
Yes.
Yep. And I'm sure
maybe you can go through it and answer some of the questions. Most of them are in there.
Right.
Yeah.
You can find it, and I think we're all on. Maybe can people find you on LinkedIn or so?
Yeah. I added it to my
Perfect.
profile. Yeah.
Perfect. Okay. Thank you. Thank you.
Thanks, Anna. Thanks, Felix. See you next time.